Hello everyone, today I am going to discuss about SR flip-flop. So I have already discussed about gated latch. So what is the difference between a gated latch and a flip-flop? A gated latch uses enable input and a flip-flop uses clock input. The function of clock input is same as that of enable input. Now coming to the block diagrams of SR flip-flop. These two are the block diagrams of SR flip-flop. Coming to the first one, this block diagram consists of two AND gates and two NOR gates. There are three inputs. The two are S and R input and the third input is the clock input. And its function is similar to that of gated SR latch, which I have discussed in my previous video lecture. Now coming to the second block diagram. This block diagram of SR flip-flop uses 4 NAND gates. These 4 are NAND gates. This is S input, this is R input, this is clock input. And the function of the working function of this gated SR latch is already discussed. Now coming to the state diagram of SR flip-flop. SR flip-flop can have only two states. One is 0, another is 1. So we can say this is a bistable device. Now when it is at 0 and in next state it is again 0, then we can draw a line like this. This line means from the previous state it is again going to its next state. And if the output of flip-flop is 0, that means the flip-flop is reset. Next, it is going to state 1 from state 0. Then we can say that if the output of flip-flop is 1, that means the flip-flop is set. So the flip-flop is going from state 0 to state 1 like this. Again, if the present state output of the flip-flop is 1, again the next state output is also 1. Then we can draw the line like this, that means from 1 to 1, and output 1 means flip-flop is set. Again it is going from 1 to 0. That means again it is reset. So this is the state diagram of SR flip-flop. Now we will discuss about the characteristics equation of SR flip-flop. So characteristics equation means we have to find out the equation of its next state using the values of S and R and its present state. So to do it, first let us discuss about the present state next state table for SR flip-flop. Now let us assume the present state is, that is Qn is 0 and both S is 0, R is 0. Then it will remain in its previous state in the next state. So the next state output will also be 0. Next we are giving S equal to 0, R equal to 1. If S equal to 0, R equal to 1, that means the flip-flop will be reset. So whatever be its present state value, be it 0 or 1, it will be reset. That means its next state value will be 0. Now coming to the third case where S equal to 1, R equal to 0 and the present state output value is 0. Now we know that if S is 1, then whatever be the value of R, it will be set. That means its next state will be 1. Next coming to S equal to 1, R equal to 1. If A is equal to 1, R equal to 1, we know that this is the forbidden case, or we can denote the next state as D. D means don't care. So we will don't care about the output of the flip-flop when both are 1. Next, we are assuming that the present state output is 1 and we are giving A is equal to 0, R equal to 1. So its output will continue to remain in its previous state. So its output will also be 1, same as this. Now again we are putting A is equal to 0, R equal to 1. Now whatever be the value of present state, if A is equal to 0, R equal to 1, flip-flop will be reset. That means next state will be 0. Then we are giving A is equal to 1, R equal to 0. If A is equal to 1, that means its next state will also be 1. Now again we are coming to the 1, 1 condition. When both the inputs are 1, next state can be denoted by D. D means don't care. Now coming to the excitation table of SR flip-flop. This is the excitation table. So how to put values in this table? First, let's come to this present state next state table. Here we can see that for these two cases, both the present state and next state values are 0. For these two cases, and here the value of S is fixed at 0 and the value of R is changing. So we can say that when both present state, next state are 0, the value of S is fixed, it is written as 0, and as the value of R is changing, so we will not care about the values of R. So we are writing here D. D means don't care. Don't care means it can be either 0 or 1. Next, coming to the condition where present state is 0, next state is 1. So this is one condition when present state is 0, next state is 1. Here value of S is 1, R is 0. So we are writing down A is equal to 1, R equal to 0. Next, coming to the condition where present state is 1, next state is 0. This is the condition when present state is 1, next state is 0. Here A is equal to 0, R equal to 1. So we are just writing down A is equal to 0, R equal to 1. Now coming to the case where both present state value and next state value both are 1. So both are 1 for these two cases. For this case where the present state is 1, next state is 1, and for this case here also the present state is 1, next state is 1. Now if we compare the values of S and R for these two rows, we can find out that the value of R is fixed at 0 and the value of S is changing. Here the value of S is 0, value of R is 1. So here we will not care about the values of S and the values of R is fixed. So we can write down here R equal to 0 and S equal to D. D means it can be either 0 or 1. We don't care about the values of S. Now coming to the K-map or Karnaugh map. So a Karnaugh map for the next state transition can be drawn using this table. So here this is the S and R input values, this is Qn. So coming to the Karnaugh map, 0, 1, 2, 3, 4, 5, 6, 7. Again this is 0, 0, 0, 1, 1, 1, 1, 0, this is 0, this is 1. Now when S and R both are 1 and the present state output value is 0, then what will be its next state output value? It will continue to remain in its previous state. So next state output value will be 0 here. Now we are giving S equal to 0, R equal to 1. When S equal to 0, R equal to 1, then and the value of Qn, that means the present state value is 0, then its output will also be 0, as R value of R is 1. So Qn plus 1, or the next state output value is 0 here. Now coming to the condition when both the inputs S and R are 1. We know that when both inputs are 1, this is the forbidden case or don't care case. So we are putting the value of next state output as D. Now coming to the case where S equal to 1, R equal to 0 and present state output is 0. If S equal to 1, that means the next state output will be set. So next state output will be 1 here. Okay. Now coming to this second row of the K-map where the present state output is 1. Present state output is 1 and S, R both are 0. That means the next state output will continue to remain at its previous state. So next state output will be 1 here. Again, S equal to 0, R equal to 1. That means the next state output will be 0. 0 here. It is the value of next state output. Again, both are 1, S and R. So the next state output will be D. Don't care. Again, S equal to 1, R equal to 0. That means the next state output will be set. That is, it will be 1. So from this K-map, if we write down its characteristics equation, then first we have to find out the prime implicants. So this is these two ones, they can form a group like this. Again, this one and this one, they can form a group. So this one, they can form a group. So for these two ones, value of S is 1, R is 0. So we can write down Qn plus 1 equal to S R bar. Now for the second group, that is this one and this one, here value of, for this one and this one, the value of Qn is 1 and the value of R is 0, that is fixed, and value of S is changing. So we are taking here the value of Qn and the value of R. So we can write down as R is 0, so it will be R bar, Qn is 1, so R bar into Qn. So this will be the characteristics equation for the next state, that is Qn plus 1 equal to S R bar plus R bar Qn. We are taking R bar as common, so we can write down S plus Qn into R bar. So this is the characteristics equation of an SR flip-flop. Thank you.